We saw previously that chaining two full adders together allows us to add numbers with 2 bits each. So if you haven't watched that video already, I've linked it below in the description. Now we can continue to chain full adders together to be able to add numbers with 4 bits, but let's use an integrated circuit instead, because the process just becomes repetitive. So I'm going to delete this full adder, and we'll get rid of these 2 integrated circuits and the wiring, and instead we're going to add 1 dip switch to represent each 4-bit binary number. So let's just copy this and connect all the switches to the positive terminal of our power supply. So we'll do that in red. And when we add 2 4-bit binary numbers, as you can imagine, we're going to need 4 bits to output the sum of each pair of bits, and then plus a carry in the end. So we're going to copy this LED to output the sum of each pair of bits. So we're going to have 4 pairs of bits being summed, and then finally a carry in the end. So for example, if we're going to add 1 1 1 1 plus 1 1 1 1, so 1 plus 1 is 2, so put down a 0, carry the 1. And then 1 plus 1 plus 1 is 3, so we put down a 1, carry the 1. And then 1 plus 1 plus 1 is 3, so put down a 1, carry the 1. And then 1 plus 1 plus 1 is 3, so put down a 1 and output the final carry. So as usual, we're going to connect the cathode of the LED to the ground, so that doesn't change between the circuits we've looked at so far. So let's do that. And now I'm going to add our integrated circuit that's going to add our 2 4-bit numbers. So this will be a 4-bit adder. And if you want to look up the data sheet, the integrated circuit is 74HC283. And this has 16 pins, which is different to the NOT gates and AND gates and so on that we've looked at already. But one thing that's common is the power. So this pin goes into the positive terminal of the power supply, and the ground goes into the negative terminal. And here we have an output bit, 0, 1, output bit 2, and output bit 3. So that's basically the output from summing each pair of bits in those binary numbers. And then finally we have a carry out that does the final carry. So let's take the least significant bits of our binary numbers. So I'm going to take this dip switch representing our binary number A, and this dip switch will represent the number B. So what we're doing is adding our number with the bits A0, A1, A2, and A3. To our other number having bits B0, B1, B2, and B3. So we're going to take A0, being the least significant bit, to the input pin 0A. And we'll color this in green. And then we'll take B0 and that's going to go to this pin over here, input 0B. And then the output bit is going to go to this LED to the far right. So this LED is going to output the sum of these least significant bits. And then following the same pattern, we'll take a blue wire from the next bit of our binary number A, and that's going to go to input 1A. And then this bit from binary number B is going to go into input 1B. And then the output is going to go into our next LED. So this is the sum of the next two bits. And we continue the same process. So we'll just take a different colored wire. And the next significant bit is going to go into input 2A. And similarly, for our binary number B, that's going into input 2B. And then the output will be the sum of these bits. So that's going to go into our next LED. So that's the output of the sum of these two bits. And then finally, we're going to take our final bit from each number. So we have input 3A. And then this bit here is going to go into input 3B. And then the output from this pin is going to be the sum of the next two bits. So that will be these two bits over here. And then we're going to output our final carry in grey. So that will be from this pin over here, being the carry out. Which goes into this LED over here. And now let's run our simulation. So as expected, summing two binary numbers with all zeros will output all zeros. And now let's test our case, being 1111 plus 1111. So as expected, we get 4 ones and a 0. So on, and off. And let's test 1001 plus 1110. So we have 1001 and 1110. So we get 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. Then 1 plus 1 is 2. So we put down a 0 and carry the 1. So as we can see, we have on, off, on, which gives the correct result. And I encourage you to test the circuit for different inputs for those binary numbers.